Welcome to Module 4, Lesson 5. So once again, and I'm going to say this a couple of times, what we're doing isn't necessarily new. But still, please pay attention, please be focusing, because we are going to get to a point where things are going to be a little bit different, and when we get there, I really want you to be with me on that. So, as we get into this, our goal today is being able to say, I can form rectangles by tiling with unit squares to make arrays. So instead of just reading them, now you are making them. Or maybe you're missing a part and you're finding a bit of it. And so, once again, nothing too crazy on this, and I'll show you guys what I mean by that in a second. So, let's say you had a picture like this. You knew that it was 4 tall, but you don't know how long it is, but you do know that the entire thing is 20 square inches. Now, going off of this, this should look relatively familiar. Now, let's look at this as if it's not a like a rectangle that you are using to find the area. Let's look at this as if it's an array. So let's look over to the right and let's make a multiplication sentence. We have something times something equals, well, the total something. Remember, beginning you always start with groups. Then you go to how many are in each group and then your total. So let's fill this chart out real quick. How many groups do I have? Well, 4. I'm going to put 4 right there. Do I know how many are in each group? I do not. So I'm just going to put a R for that right now to represent that we're looking for R. And do we know our total? Well, yeah. We know our total is 20. So I have this equation. I need to find out what R is. So I need to find out 4 times what equals 20. Now, there's a couple ways you can do this, and I'm going to show you the way that does not work very well first. What you could do is be like, okay, so I'm just going to take this, I'm just going to copy it over and over and over and over and over, and when it's filled, then I'll get my answer. Technically, you're right. That could work. But the problem with that is that we are human. We make mistakes. I know for a fact, as I draw this out, this is not going to give me exactly what I want. And so we'll solve this so we know what the answer is, what our missing number is up here, and then I'll show you why my method doesn't work too well. So, anyways, I digress. So 4 times what equals 20? Let's just skip count by 4 until we get to 20. So 4, 8, 12, 16, 20. So the answer is 5. So 5. So that means I need to have a total of 5 in each one of these. Now, that means I need to have 1, 2, 3, 4, 5 across. But I'm going to show you how just copying it over can sometimes mess you up. So I'm going to say, okay, I think they're that big, so I'm going to make it like that, and just keep doing that all the way across like that. And then, of course, cross like that. Then you'd have 1, 2, 3, 4, 5, 6, 7. So, once again, if you notice, these are kind of small and they get a little bigger going across. But you always have to remember, sometimes these drawings, especially if you're drawing it yourself, I drew this, so it's not 100% accurate. Sometimes it can be a little off, so I'd go more off by the number. Because going off of that, the answer is 1, 2, 3, 4, 5, 6, 7. But I made a human error. I made a human mistake of the sizings not being just right. So I'm going to go ahead and erase that up, because I now know the answer should be 5. So I can now fill this up entirely to the best of my ability to, measure it out right. So 1, 2, 3, 4, and then you can cut it right there. And now it's a little bit better. Now, once again, the entire idea here is that every single one of these is the exact same size. Humanly, sometimes that's not possible unless you take a lot of time and really slow doing it. But we get the idea with this. We get the idea that there's 1, 2, 3, 4, and 1, 2, 3, 4, 5 across. And we understand that what I'm getting at is that they're all the exact same size. Now, on your homework, in your problem set, you can use a ruler to actually do this. I do highly recommend being able to recognize and solve it this way, because that's coming down the line. You need to be able to do that. But let me show you what happens when you draw it exactly to what you need to be doing. So we had it being 4 long, and I'm going to do inches since inches are a little easier for you to see on this screen. So 4 this way, and then it would already be measured out accordingly going that way. Just making sure I made it a little bit too tall, so take off 1 right there. There you go. So once again, the reason why I'm not doing this every single time is because I'm trying to make it a little bit bigger so you guys can see more accurately. So you're not like squinting and being like, okay, what's going on? But I want to show you how this is if I were to do this exactly. So if this was like a problem on your book, you would have something that looks similar to this. And you can probably already realize that this is very different from what my hand-drawn picture is. And that's okay. I'm not a computer. I don't have a ruler attached to my hand that can always measure this perfectly. So just kind of keep that in mind. Human error is a thing. That's why we want to, in our pictures, we do our very best to make them accurate. Sometimes they're not going to be perfect, but it's recognizing that we're trying to represent something that mathematically is perfect. So this is what you would have had. You would have had 4, you had a question mark right there. We would have found the answer is 5. So if you got your ruler, at this point, you could just take this, draw it across like this, drop it down again, draw it across like that, do it again, draw it across, and then, a little bit of a dip down. See, even I'm using a ruler, I'm still not making it absolutely perfect. But then I can draw it right down here, really find that there's an inch there, and an inch there, and then do my very best to draw those lines straight up. Now this is probably going to look a little bit closer to what the actual picture would have been. Still not perfect, but you probably would have gotten something closer to that. And you guys are more than welcome to do that. You have a ruler or a straight edge of a piece of paper, go for it. You're totally fine to do that. But just remember, your drawing is representing a perfect answer, a perfect number. But your drawing ability, including mine, might not be perfect. So just remember, your drawings are representing a perfect problem. Your drawings themselves may not be perfect. So don't get a problem wrong because you made something too big or too long or so on and so forth. So that's kind of what today is about, is just being able to identify missing parts, being able to fill those in, etc., etc., etc. Another way of doing this is if I just had a blank box right here. And I said this side was 3 and this side was 6. Then you would need to be like, okay, there's 3 on this side. And once again, to the best of your ability, try to make it as even as possible. Make 1, 2, 3. And then over here, make it 6 to your best ability. Is it possible that as you're doing this, you might make a mistake, you need to erase something and fix something, like, oh, I made those too big or made them too small, and rearrange? Yes, very much so. If this is your first time doing something like this, you're going to need to do that. I still need to do that, and I've had a lot of practice doing it. So you will probably definitely, if you can do it perfect, wow, awesome, that's great. But just keep in mind, if you need to respace things out, take the time to do that. So make it 6. So I'm going to make 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Once again, it's not perfect, but it's representing something that is. So now we have 1, 2, 3, which is represented by this 3. We made 3 because it tells us 3. And 6, 1, 2, 3, 4, 5, 6. And we made 6 because it tells us it is 6. Now 3 times 6 goes 6, 12, 18. Should be 18 squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it works. Just kind of keep that in mind. I also want to mention one more thing before we wrap this up. If you had a shape that was a 6 by 2, would your shape be like that? Or would it be taller and skinnier? So once again, not perfectly drawn, but this is an important thing to remember as well. If every single square is hypothetically supposed to be the exact same shape as we're drawing them, these ones are going to be really skinny this way if we draw it like this. Remember, just like an array, if there's more groups than there are in each group, it's going to be longer. 6 by 2 is going to be very long because there's 6 in each group. So 2, 3, 4, 5, 6, with 2 in each like that. This one up here would more likely be a 2 by 6. With 2, 3, 4, 5, 6 like that. Once again, not perfectly drawn, but you get the idea. So just keep in mind, if you had something that's super long and skinny, there's no way that that would ever be like 1 by 10 or anything. That's not reasonable at all. So just kind of keep that in mind. So that is kind of the majority of that, is recognizing that you can still find an answer regardless if you're missing the lines inside, missing one numbers on the side, but you know the total. It's kind of what we've already been doing. We're just doing it for area now. So hopefully this was helpful. Hope you guys got some practice in, and hope you guys have a great day.